Alright, next up we're going to do section 8 of chapter 8, which is called Solving Equations with Radicals. So again, in chapter 7 we talked about solving equations with rational powers. This is basically the same thing. We're just doing the same thing, we're just writing it with radicals. So, first step, we want to get the radical by itself. Then we want to take the appropriate power, which is going to be the reciprocal of whatever exponent you have. And then you want to check your solution, because remember, sometimes you can create extraneous solutions that don't actually mean anything. Okay, so for this first problem here, the first thing I want to do is get the radical by itself. So I'm going to start by subtracting 2 from both sides. So I have the cube root of x equals 7. Now if I have the cube root of x, remember that that's x to the 1/3. If I want to get rid of that 1/3 power, I can take it to the reciprocal power, which would be the third. Think about it this way: if you have a square root, you want to square it in order to get rid of the square root sign. We're doing the same thing here. I have a cube root, so I need to cube it in order to get rid of that. And if I do it to one side, I have to do it to the other side also. So if I type 7 cubed into my calculator, I get 343, so I get x equals 343. Alright, next up, I've got 5 times the square root of 3x plus 1 equals 80. Remember, my first step is to get the radical by itself, so I'm going to start by dividing by 5. So I have the square root of 3y plus 1 equals 80 divided by 5, which is 16. Okay, now I've got a square root here, so what I can do is I can square both sides. And when I square both sides, I get 3y plus 1 equals 16 squared, which is 256. Now remember, when you square a square root, okay, you can get 2 possible answers. You can get the positive answer or the negative answer. So technically speaking, when I have an even power and I'm raising it to an even power instead of an odd power like I was over here, I could get more than one solution, meaning that this needs to be an absolute value problem. So how do you solve an absolute value problem? Well, you have to split it up into either the positive or the negative solution. So if I split that up, I could have either 3y plus 1 equals 256, or I could have 3y plus 1 equals negative 256, depending on whether it's my positive or my negative solution. So then when I go through and I solve this, I subtract 1, I get 3y equals 255, and then I divide by 3, and I get y equals 85. Over here I can do the same thing for the negative, so if I subtract 1, I get 3y equals negative 257. And then if I divide by 3, I get y equals negative 85 2/3. Okay? So now is when I need to go back through and I need to decide, is that actually a solution or not? Okay? So if it is a solution, that means that I should be able to plug it back in and get the correct answer. So go ahead and take a second to try to plug this 85 back in. Okay, so once you plug that 85 back in, you should realize that it is a solution. Now let's go through and try to plug this negative 85 2/3 back in. So if I plug it in here, I've got a big negative number plus 1. Okay, so what happens when I try to take the square root of a negative number? I get an imaginary number. So this is not going to be a solution because this is not equal to an imaginary number. So I can cross that solution out and I can say that this is the only solution to that problem. Okay, now I'm going to do the same thing over here. So again, my first step is to get the radical by itself. So I'm going to start by subtracting 5 from both sides. So I have the fourth root of 2x minus 5 equals negative 4. If I want to get that power, if I want to get rid of that root, okay, I need to take it to the fourth power. Remember, you have to do that to both sides. Okay, so now, again, this was an even power. So I have to do the same thing again. Whenever I take an even power, I need to use the absolute value sign. Because I know that with even powers, I could either get a positive solution or I could get a negative solution. So this is going to be the absolute value of 2x minus 5 equals 256. So I can split that off into the positive and the negative. So I could either have 2x minus 5 equals 256, or I could have 2x minus 5 equals negative 256. If I solve this one over here, I add 5, and I get 2x equals 261. Yep, and then I divide by 2, and I get x equals 130.5. Okay, over here, if I add that 5 on, I get 2x equals negative 251. And for my x, I get x equals negative 125.5. So again, now I need to go back and I need to check my answers. I need to figure out would they work. So if I plug this back in, you should notice that you get an answer that works. That's good. Okay, so that is definitely an answer. Now I'm going to go through and I'm going to try to plug this negative number back in. And when I plug it in, you'll notice that this I have a negative underneath a even root, which means that I cannot have that answer. It would become imaginary. So this solution would not work. And 130.5 is the only solution. All right, that's everything for section 8.